This is Professor Pelton. This is Trigonometry Chapter 2, Section 2. We'll be graphing cosecant and secant in general. Okay, so if we look at the first quadrant, oops, let me turn the pen on. Alright, everything is positive in the first quadrant. And the first coordinate is 1, 0 for cosine sine. Okay, well, we're not doing cosine or sine, we're doing secant. Well, secant is sine reciprocated. So if I have 0 over 1 for sine, then cosecant is 1 over 0, which is undefined. Which means I do not have a coordinate, I have an asymptote because I cannot divide by 0. To abbreviate there. Okay, so the next one is 30 degrees, which is pi over 6. That coordinate, 30 degrees, pi over 6, is root 3 over 2, comma 1/2, cosine sine. But again, we don't want sine, which is 1/2. We want the reciprocal, which is 2 over 1 for cosecant. So the cosecant of pi over 6 is in fact 2 over 1. So I plug in pi over 6, I'm going to get 2 as my answer. Okay, next one, cosecant of 45 degrees. It's pi over 4. Right there, so that's root 2 over 2, comma root 2 over 2 for cosine sine. So if I reciprocate sine, I'll get 2 over root 2, which means I plugged in 45 degrees, and I get 2 over root 2. Okay. Pi over 3, 60 degrees, so the cosecant pi over 3 equals a 60-degree angle. Right, so that's where we're going so far for our unit circle. So that coordinate is 1/2 root 3 over 2. So if I reciprocate root 3 over 2, I get 2 over root 3. So at pi over 3, I get 2 over root 3. Okay, so to finish off the first quadrant, we have the 90-degree angle, pi over 2, which is a coordinate of 0 over 1. So if sine is 1, that's really 1 over 1. So if I reciprocate it, I still get 1 over 1. So the cosecant of pi over 2 is 1 over 1. So if I plug in pi over 2, I get 1. Okay, so let's think about the other quadrants now, because the answers repeat. So in the second quadrant, I get negative positive answers. Then I get negative negative answers in the third quadrant, and positive negative answers in the fourth quadrant. But I'm only concerned with sine, because the reciprocal of sine is cosecant. So it means I'm going to be positive in the next quadrant, and then negative in the last two quadrants. Okay, so the answers repeat positive, and then 2 more times negative. Okay, so let's do the next quadrant. So if we do the cosecant of 2 pi over 3, we're going to get 2 over root 3. So 2 pi over 3 gives you 2 over root 3. And if we do the 3 pi over 4, that's going to give us 2 over root 2, just like it did for the pi over 4 angle in the first quadrant. So 3 pi over 4 gives us 2 over root 2. And cosecant of 5 pi over 6 is the same as the pi over 6 in the other one. I'm going to get 2 over 1, as it's 1/2 for sine. So at 5 pi over 6, I get 2. That's a little bit sloppy. Let's fix that up here. Okay, so next we have pi, so cosecant of pi. So the ones that do change typically are the ones at the quadrantal angle. So if I think about if I'm at pi, I made it all the way to there, so I've now finished the second quadrant. Well, that coordinate is negative 1, 0. So the sine value is 0. So if I flip 0 over 1, I'm going to get 1 over 0, aren't I? Which is undefined. So that means I actually have an asymptote at pi. Okay? Alright, so now we're in the third quadrant, which means I'm going to be negative. And the fourth quadrant, I'm also going to be negative. So same answers again, but negative. So let's do the last two quadrants. So it's 7 pi over 6. Cosecant of 7 pi over 6. I'm going to be negative 2. So 7 pi over 6, I get negative 2. Okay. At 5 pi over 4, that's going to be the 2 over root 2, but now I'm negative since I'm in the third quadrant. So 5 pi over 4 is negative 2 over root 2. Let me change that 7 pi over 6, make it a little bit neater. Okay, 4 pi over 3, so cosecant of 4 pi over 3 is the 2 over root 3, which is negative in that quadrant, third quadrant. So 4 pi over 3 equals negative 2 over root 3. And lastly, cosecant of 3 pi over 2. That's a quadrantal, so you should check that one. So at 3 pi over 2, I've gone all the way to there, right? 3 pi over 2. That coordinate is 0, negative 1. So the sign is negative 1. So if I flip that, I'm just going to get 1 over negative 1 when I get cosecant, correct? So it's just going to be negative 1 over 1. So therefore 3 pi over 2 is just simply negative 1. Okay? And lastly, the fourth quadrant is also going to be negative. So if I do the cosecant of 5 pi over 3, I get the negative 2 over root 3 again, because again we're repeating answers, because that's again the 60-degree angle. So 5 pi over 3, comma, negative 2 over root 3. And cosecant of 7 pi over 4 is the 45-degree angle. So that's negative 2 over root 2. So 7 pi over 4, comma, negative 2 over root 2. And lastly, the 30-degree angle, cosecant of 11 pi over 6 is the negative 2 over 1. So 11 pi over 6 is negative 2. And lastly, 2 pi. So now I've gone all the way around. That coordinate is 1, 0. But the sign is 0, so 0 over 1 cannot be reciprocated, because that would give me 1 over 0. That's undefined, so the cosecant of 2 pi, right, is undefined. So therefore we have an asymptote. Okay? Alright, now we can go back and make a graph. I've broke it up into twelfths. So using the values from our table, we found that at 0, oops, I need to turn the pen on. We have an asymptote at 0. We have an asymptote at pi. And we have an asymptote at 2 pi. Okay, so go through the quadrants, starting in the first quadrant. At pi over 6, we're at 2. At pi over 4, we're at 2 over root 2, so we do a little math over here on the side. 2 over root 2 is approximately 1.41. And we also had 2 over root 3 on our list, which is approximately 1.15. Okay, so at pi over 4, we're at 2 over root 2. And the next one, pi over 3, we're at 2 over root 3. Pi over 3, we're at 2 over root 3. And at pi over 2, we're at 1. Then it starts going the other way. We're backward at 2 over root 3. Then we're back to 2 over root 2 for 3/4. Oop. Thinking I skipped one. Pi over 2. Oh, I'm off. That's why. So at pi over 2, I'm at 1. So that's right there. That's why. Okay, so then the 2 pi over 3, that's right there. And then 3 pi over 4, and then the 5 pi over 6. Okay, so that concludes the first and second quadrant. Now if I go to the third and fourth quadrant, it's 7 pi over 6, I'm at negative 2. 5 pi over 4, I'm negative 2 over root 2. 4 pi over 3, I'm at 2 over root 3. 3 pi over 2, I'm at negative 1. 5 pi over 3, I'm at the same thing, 2 over root 3 again. And 7 pi over 4, I'm at 2 over root 2. And lastly, 11 pi over 6, we're at negative 2. Okay, but we don't need to be at this precise and have this many points. We can skip a lot of them and just do the ones that are whole numbers, which are the 1s and the 2s. Okay, we can skip all the rest of them by doing a much quicker graph. So the key points here is every iteration of pi is an asymptote. Halfway in between that is the value of 1, and halfway between that is the values of 2. So we can do a much quicker graph. Let's go down a little bit here. So if I just make a graph that goes by 6, I can again make the asymptotes. Oops, turn on my pen. Okay, so at pi over 2 I'm at 1, and at 3 pi over 2 I'm at negative 1. In the sixth in between, at the 1/6 I'm at 2, and at 5/6 I'm at 2. And in between at 7/6 I'm at 2, and 11/6 I'm at 2, but it's negative on the other side. So because it's first, second, third quadrant, as far as positives, then to negatives. Okay, let's try secant. Okay, so for secant, much the same, except for now we're going to do cosine. Let's actually scroll up a little bit. So if I do the first quadrant, the 0 degrees is 1 comma 0 for cosine sine. So cosine is 1 over 1, right? So we're doing cosine right here. So if I flip cosine 1 over 1, I still get 1 over 1 when I reciprocate it. So the secant of 0 is 1 over 1, thus 1. So if I do the secant of pi over 6, that is the 30-degree angle. The 30-degree angle is root 3 over 2 comma 1/2. So if I reciprocate the cosine to get secant, I get 2 over root 3. So when I plug in pi over 6, I get 2 over root 3. So next is the 45-degree angle. So I get root 2 over 2 comma root 2 over 2. So if I reciprocate cosine, the secant of pi over 4 is 2 over root 2. So when I plug in pi over 4, I get 2 over root 2. Okay. Next, I get the 60-degree angle, which is 1/2 root 3 over 2. So if I flip the cosine, I'll get 2 over 1. So the secant of 60 degrees is 2 over 1. So pi over 3 is 2 when doing secant. And lastly, the secant of pi over 2 is at the 90-degree angle. So we've gone all the way through the first quadrant now. And that coordinate is 0, 1. So the cosine is 0. So if I take 0 over 1, which is 0, and reciprocate it, I get 1 over 0. Well, that's undefined. So that's undefined. Since I can't divide by 0, that is an asymptote. Okay? Alright, so that ends the first quadrant. So what happens for the rest? So this is the positive quadrant. This is the negative quadrant, negative quadrant, and positive negative quadrant. Since I'm only concerned with cosine, right, since this is a secant function, we're only concerned with cosine, I'm going to be negative in the next two quadrants and positive in the fourth. So I'm going to be negative, negative, then positive. Okay, let's finish the table. Okay, so all these answers should be negative in these next two quadrants. Okay, so we left off at pi over 2, so at 2 pi over 3. So the secant of 2 pi over 3 would be negative 2 over 1. So therefore 2 pi over 3 is negative 2. And then we have the secant of 3 pi over 4. That's the 45-degree angle, so 2 over root 2. But negative, of course, in this case. And then we have 5 pi over 6, which is the 30-degree angle. So the secant of the 30-degree angle in that quadrant is the negative 2 over root 3. So 5 pi over 6 is negative 2 over root 3. So lastly, we get to pi. So the secant of pi. Okay, so if we look at the pi, it means I get all the way around to here. And that coordinate is negative 1, 0. So that is the cosine. So the reciprocal of negative 1 over 1 is still negative 1 over 1. So that gives me at pi, I am at negative 1. Okay, so I repeat myself in the third quadrant now for being negative. So the secant of 7 pi over 6, which is the 30-degree angle again, gives you 2 over root 3 again, but negative. Five pi over 4 is the 45-degree angle. So negative 2 over root 2. So 5 pi over 4 is negative 2 over root 2. And the secant of 4 pi over 3 is the 60-degree angle. So that gives me negative 2 over 1. So 4 pi over 3 gives me negative 2. And 3 pi over 2 ends the third quadrant. So now I've gone all the way around to there, 3 pi over 2, which is the 0, negative 1. So my cosine there is 0. But if I reciprocate 0 over 1, which is 0, I get undefined, don't I? So that means I have an asymptote there also. Okay, so now I'm in the last quadrant, which is positive, negative, which means my final answers are going to be positive in this quadrant. Let's finish out the final quadrant for secant. Okay, so 5 pi over 3. Oops, pen didn't turn on. The secant of 5 pi over 3 is the 60-degree angle. So that's 2 over 1. So 5 pi over 3 is 2. And the secant of the 45-degree angle is 2 over root 2. So 7 pi over 4 is 2 over root 2. And the secant of the 30-degree angle in the fourth quadrant is the 2 over root 3. So at 11 pi over 6, I am at 2 over root 3. And lastly, the secant of 2 pi means I made it all the way around. So if I think about going all the way around, right, that means I made it back to 2 pi, which is the 1, 0 coordinate. Since cosine is 1, the reciprocal is still 1 over 1. So at 2 pi, I'm at 1. Okay, let's go to the top, make a very exact graph, and then a quicker graph below that. Okay, so as we found in the table, every half pi, we have an asymptote. Okay, so the half, pi over 2, got an asymptote. And at 3 pi over 2, we had an asymptote. There are more than that if you keep going either direction, but for the sake of just graphing 2 pi, we'll stop there. Okay, so at 0, we're at 1. And at pi over 6, we're at 2 over root 3, so we should do these again. So 2 over root 3 and 2 over root 2. Those are approximately 1.41, right? And that was 1.15. Okay. So at pi over 6, we're at 1.15. And at pi over 3, we are 1.41. And at pi over 2, we are undefined. So we're just going to go up like that. Oh, I'm sorry. Pi over 3 is 2. What am I saying? Pi over 3 is 2. I got my points wrong here. So the ones I did were 0, pi over 6, pi over 4, pi over 3. Pi over 2 is undefined, obviously. That's the asymptote. So at 2 pi over 3, we're at negative 2. 2 pi over 3, we're at negative 2. At 3 pi over 4, we're at 2 over root 2. At 5 pi over 6, we're at 2 over root 3. At pi, we're at negative 1. 7 pi over 6, we're also at negative 2 pi over 3. At 5 pi over 4, we're at negative 2 over root 2. And back to 4 pi over 3, we're at negative 2. Okay, and the last quadrant, at 5 pi over 3, we're at positive 2. At 7 pi over 4, we're at 2 over root 2. 11 pi over 6, we're at 2 over root 3. And at 2 pi, we are at 1. Okay, and of course these cycles repeat each other, of course, if we wanted to keep going. But that's fine. All right, so we don't need to do this much detail. We can just do the ones that are 1 and 2 and negative 2 and negative 1. That'd be a lot quicker graph. So instead of doing it by twelfths, I'm going to do it by sixths. So again, same thing is true, that every half, there's an asymptote. Oh, that didn't work. Let's see if I can try that again. There we go. So every half is an asymptote. Okay, so we're at 1 at 0. We're at negative 1 at pi. And we're at back to positive 1 at 2 pi. Okay, and in between, we're going to be the values at 2 on every third. So I'm going to be at 2, negative 2, negative 2, and positive 2. So that completes our graph. We can do more than one cycle if we want. Right? And the quarters and the sixths are obviously the decimal values, the 2 over root 3 and 2 over root 2. Okay, so that's one cycle of the first 2 pi of either of those. So let's look at the overall characteristics now. So in general, you can graph cosecant by using the sine graph. They follow the same pattern. Okay, so if you use the same rules for sine, you can get a cosecant, and likewise, you can use the same rules for cosine to get secant. They follow the same. Okay, so the period is still going to be the same, 2 pi, for both cosecant and sine. The domain is going to go forever left and forever right. Okay, so basically everywhere, except where n pi, where n is a member of the integers, because at every whole pi, 1 pi, 2 pi, 0 pi, negative 1 pi, negative 2 pi, there's going to be an asymptote. So the range is negative infinity to negative 1, union negative 1 to infinity. I'm sorry, positive 1, excuse me. Because each one of these is 1 or higher, or negative 1 or less. Okay? For cosecant. Alright, so for secant, Okay. Since it follows the cosine graph, it's still 2 pi for every iteration, right? Because 1 up and 1 down is an iteration or cycle or period for both secant and cosecant. Okay, so the problem here is every half pi, there's an asymptote, isn't there? Every half pi, okay? So it's n pi over 2, so it's everywhere, right? All real numbers except n pi over 2, where n is a member of the odd integers. You don't want even because 2 over 2 is 1. It'd be a whole number, right? So 1 half, 3 halves, 5 halves, so on and so forth. You don't want the even number. And negatives, of course. And the range is negative infinity to negative 1, union positive 1 to infinity. Because the top half is 1 to infinity. The bottom half is negative 1 to negative infinity. Okay? That's the end of this part.